let's investigate part B of this standard. But before we really get going, we need to concentrate on this idea of multiplication, the representation. What does 3 times 2 fifths really mean? Back in 3rd grade, there's standard 30A-A1, and it really sheds some light on this. There's some clarification here as to how to interpret something like 3 times 2 fifths. This 3rd grade standard says to interpret 5 times 7 as the total number of objects in 5 groups of 7 objects each. So that's the key as to how to interpret the numerals that are involved in multiplication. If we have something like 3 times 4, the interpretation says that we have 3 groups of 4 in each one. And it's 3 groups of 4 objects or items of some sort. It could be, let's say, 3 groups of 4 cars each. Or it could be, say, 3 groups of 4 pencils. Now it makes it clear, 3 times 4, students really need to see that as 3 groups of 4, and specifically 3 groups of 4 somethings. So when we see 3 times 2 fifths, students need to see that as 3 groups of 2 fifths. Looking at the symbolism, even though it says 3 times 2 fifths, what's in students' minds should be 3 groups of 2 fifths in each one. Rather than jump in and just work with the symbolism, it's better to use some type of physical representation. Students really need to see what's going on, because with fractions there's a whole lot of symbolism and it needs to make sense to them. So let's again use some physical representation. So we start off with 3 groups of 2 fifths. What is that equivalent to? Well, let's do this strictly doing the visuals. Let's go ahead and move this set of 2 fifths over to the other one. So we've done that. We have one more to fill in here, but we have 2 over here, so let's just move one of those over here. Now let's take the one that's left and move it over here. And now students can visually see exactly what happened, and the solution will make sense to them. We don't need this over here anymore. If we count these up, we have 1, 2, 3, 4, 5, 6. Each one of those parts is 1/5. So our solution is 6 fifths, which symbolically and connecting back to this standard would be 6 times 1/5. Using our physical representation, students should see that the 3 groups of 2 fifths was equivalent to 6 groups of 1/5 in each one. Let's rewrite this to where we have 6 over 5 to connect it back to what the standard says. Let's change this up a little bit. Instead of having 3 times 2 fifths, let's look at 2 times 3 fifths, which of course would be 2 groups of 3 fifths each. Rather than just use some blind multiplication, again, let's solve this using just our visuals, our physical representations. What we need to do is take 2 fifths from our hole on the right and move them over to our hole on the left. So let's do that. And bingo, we have what we need. We have 6 1/5 again. Symbolically, that's 6 times 1 over 5, which again is 6 groups of 1/5. And symbolically, that's 6 over 5. Our first example, we did 2 groups of 3 fifths. Then we switched it around a little bit and we did 3 groups of 2 fifths. In both cases, when we did our manipulation with our physical objects, we got 6 fifths. Let's conclude by looking at the very last part of the standard. This generic representation of a whole number times a fraction, where on the left-hand side, the equation says n times open parentheses a over b close parentheses being equal to open parentheses n times a close parentheses all over b. It would be a little bit difficult to show this with just symbols. It's just too abstract. So let's go with what we've been dealing with. Let's use 6 over 5. Let's stick with the example that's in the standard. 3 times 2/5, and let's set it equal to itself. On the left-hand side, we know that we have to multiply the 3 and the 2 to get the 6. And the same thing applies on the right-hand side. We need to multiply the 3 and the 2 to get the 6 also. Let's look at the left-hand side of the equation. The left side is really pretty simple. All we need to do is put parentheses around the 2/5, and our specific numeric example corresponds exactly to what the general form says in the equation in our standard. So that was easy. It is the right side of the equation that's going to be a headache. Let's see what we have to do. Somehow we need to have the 3 times 2 all in the numerator. So let's work on that. Okay, the 3 times 2. Well, what can we do? Well, we need to work on the 3. We can make that into a fraction, 3 over 1. So now we have 3 over 1 times 2 over 5. We can now take that and convert it to just one fraction. So we've taken care of the more difficult part here. The 3 times 2 in the numerator we can put in parentheses, and it matches our generic form. Now our only problem is to make the denominators look the same. Well, we have the 1 times 5. We need to get rid of the multiplication there. We need to get rid of 1 times. So what can we do? Well, that's just the multiplicative identity. 1 times any number is not going to change that quantity, so we can just drop the 1 times, move the 5 over. Now we have the right hand side of the equation being exactly like it is in the generic form. So on the left hand side, we can now take our specific example and make it look like the general form, and then the same thing on the right. And so we're pretty much done here. We've shown that these are equivalent, and hopefully by doing this with a specific example at this level, students can see that they are in fact equivalent to each other. So this idea of a fraction a over b, we work with multiplying a whole number times our fractional part. We used 6 over 5 as our example, so 6 over 5 would be 6 times 1/5. But what if we took our generic example and use our commutative property? Let's switch this around to where it's 1 over b times a. At this level, it's okay to use numeric examples to sort of informally prove something. So let's do that, and let's stick again with what we're using. 1/5 times 6. What's happening here is that we really don't have a whole lot of groups. Actually, we don't even have one whole group. We have part of a group. We have 1/5 of 6. So let's use a physical representation to make it a lot more obvious to students as to what is going on. So let's have 6 objects here. Since we're dealing with fifths, let's go ahead and split all of these up into 5 equal parts. Since we are talking about 1/5, then let's take 1/5 out of each one of these. However, in this form, it's hard to tell, well, what's our total quantity? So let's do some manipulation. Let's take this 1/5 and move it over to there. We don't need that anymore, so let's get rid of it. Now we can take this 1/5 and move it there. And we can get rid of that one there. Let's take this 1/5 and move it here. Eliminate that hole. Now let's take this 1/5 and move it. Get rid of that. And we're done. We see that we have a total of 6/5, which is equivalent to 6 times 1/5. We make the connection symbolically, the 6 times 1/5 being equal to 6/5, 6/5. And we see that the commutative property does hold in this case, of course. The 6 times 1/5 is equivalent to 1/5 times 6. Let's use a slightly different approach here. Let's take the 1/5 times 6. Why don't we convert the 6 to 5 plus 1? What we need to do here is we would need to multiply 1/5 times 5, but we also have to multiply 1/5 times 1. That is based on our distributive property. So when we do this, an equivalent expression would be 1/5 times 5 plus 1/5 times 1. But this is just a bunch of numeric symbolism that may not make sense to students, so let's get our physical representation. Now, this is what's different here. So first, let's concentrate on 1/5 times 5. And then we'll worry about the 1/5 times 1 later. Now, we want 5 of those units, so let's just concentrate on that. Well, this is pretty obvious. 1/5 of 5 is simply 1, so we just need to take 1 and let's shade it to differentiate it from the others. And we don't need those other ones, so let's get rid of them. Now we need to take care of the second part here, 1/5 times 1. Let's take our physical representation, split it up into 5 equal parts, and we just want one of those. So bingo, there we have it. And we can see that we have a total of 1 whole plus another 1/5, and if we split the 1 whole into 5 equal parts, bingo, we have 6/5 just like we did before, which converted over would be 6 times 1/5, which of course is equal to 6/5 or 6/5. We've taken one example, 6/5, and we represented it in multiple ways. 6/5, 6 times 1/5, and of course, real important that students see that as 6 and then the word fifths written out to focus on this idea of the denominator actually being a noun. It was important to do all of this because it really is critical that students at this grade level understand the meaning, the details, and the nuances of the symbolism of fractions. We do this to ensure a solid foundation and a deep knowledge of fractions. Looking at our standards for mathematical practice, by doing the activities in this standard, they would reason abstractly and quantitatively. They would construct viable arguments and critique the reasoning of others. In addition, students would also use appropriate tools strategically. They would attend to precision, and they would look for and make use of structure.